Good morning, students. In the previous session, we discussed about some numerical problems based on Ohm's law and the properties of resistance, the factors on which the resistance depends, and we discussed calculation of resistivity and so on. The next important thing is resistance of a system of resistors. If in a circuit, if you require some high resistance, if that high resistance is not available in the circuit board, if that high resistance is not available in the laboratory, then what we'll do, we'll take some 2-3 resistors and combine them. And there are two ways of combination of resistors. One is series combination of resistors and another one is parallel combination of resistors. Resistor is the one which has some value of resistance. So by suitable combination of such resistances, we will be able to get required resistance in the circuit. So there are two ways of combining. So the meaning of this is combination of resistors. Combination of resistors in the circuit. There are two types of combinations. One is series combination. Series combination of resistors, and the second one is parallel combination. Parallel combination. Parallel combination of resistors. Parallel combination of resistances. So first let us study what is the meaning of series combination. If we take, we are going to discuss first series combination. Suppose we have three resistors having resistances R1, R2 and R3, maybe like 10 ohm, 20 ohm, 30 ohm. So 10 ohm, 20 ohm, 30 ohm, 10 plus 20 becomes 30, 30 plus 30 becomes 60. So if I want 60 ohm resistance, if there are three resistors 10 ohm, 20 ohm and 30 ohm, if I combine them in series, then I will get the required resistance 60 ohm. So that combination is called series combination. How is that series combination done? Let us see. So resistors connected in series. So these three resistances are connected in this fashion. So this is R1, this is R2 and this one is R3. See, the left terminal of the right terminal of the second one is connected to the left terminal of the first one. Right terminal of the third one is connected to the left terminal of the second one. Left and right combination. So this is called as series combination. If it is connected to a circuit, suppose I am taking in the circuit an ammeter which helps us to read the current. Ammeter should be always taken in series and then connected to a battery. Suppose this is a battery. Combination of cells is called as battery. This is also series combination. This is also called series combination of cells. And then connected to a key. And here, to read the voltage, we take a voltmeter. A voltmeter is connected across this combination. So this experimental setup is to study the series combination of resistors R1, R2, R3. R1, R2 and R3 are the resistors. Okay. When you close the circuit, the moment you close the circuit, then the current starts flowing from the positive terminal of the battery in this fashion, and the current I flows. The same current I flows through this. The same current I flows through this. Okay, that's how the circuit is completed. Now, at moment we will not take this voltmeter. Then there will be no confusion. So you can now see whatever be the value of resistances R1, R2, R3, the current that is flowing through the resistances here is same. Then what differs? The differing thing will be the voltage across each resistances. Voltage across each resistance differ. If V is the total potential difference provided by the battery, then this total potential difference provided by the battery is divided among these three resistances. Let us say V1 across the resistance R1, V2 across the resistance R2, and V3 across the resistance R3. If I will write here, if V is the voltage, if V is the potential difference or voltage supplied by the source here is battery, this is the source, then if total resistance of this combination, let us assume that total resistance of this combination of all the three resistances is R. If R is the total resistance of the system of the combination, then using Ohm's law, I can relate potential difference with current. V is equal to Ri using Ohm's law. V is equal to Ri, where R is the total resistance of the combination. Now V is the total potential difference provided by the battery. Now, when this V is total potential difference for this, let us say this is a terminal A and this is terminal B and this is terminal C and this is terminal D. So V is the potential difference across the terminals A and D. So as a result, the potential difference across A and B will be different. Potential difference across B and C will be different. Potential difference across C and D will be different. That potential difference depends on R1 and the current I, R2 and the current I, R3 and the current I. So the total potential difference is now shared. Now, if V is the total potential difference, then V becomes equal to V1 plus V2 plus V3. What are these V1, V2, V3? Where V1 is the potential difference across R1, V2 is the potential difference across R2, and V3 is the potential difference across R3. So that if you add this V1 plus V2 plus V3, we get the total potential difference V. But what is V? V is equal to Ri. In the same way, using Ohm's law, we can write what is V1, what is V2 and what is V3. Using Ohm's law, V1 becomes equal to R1I, because the current flowing through resistance R1, R2 and R3 is same current flows. You see, the current entering here is I, the same current enters here through R2 and the same current enters through R3. So the current entering and leaving here is I, as I have mentioned here. Same current I flows. Therefore, V1 is equal to R1 I, V2 is equal to R2 I, product of R and I, V3 is equal to R3 I, using Ohm's law. R2 I, V3 is equal to R3 I. Reason is because the current I remains same through all resistances. So that now I can substitute what is the value of V1, V2 and V3 in this equation. And what is the value of V? V also we know. V is equal to Ri. So that we can substitute and get the result for total resistance. So I can substitute now V equal to V1 plus V2 plus V3. What is V? V is equal to Ri, left hand side. Ri equal to, what is V1? R1 I. R1 I, because the current I remains same. Then V2 equal to R2 I plus V3 equal to R3 I. So once we substitute this, you see I remains same. So R into I becomes equal to R1 plus R2 plus R3 after taking common I. So I cancels, I is common, I cancels, thus we get total resistance. Total resistance R is equal to R1 plus R2 plus R3. This is what we call as series combination. Therefore, in series combination of resistors, the total effective resistance R is equal to sum of the individual resistances. So in series combination, the total net resistance, also you can call total net resistance or total effective resistances. Total effective resistance is equal to sum of the individual resistances. So here we have taken only 3 resistances. If it is 2 resistances, then R is equal to R1 plus R2. If it is 4 resistances, then R is equal to R1 plus R2 plus R3 plus R4. If it is n resistances, then R is equal to R1 plus R2 plus R3 plus and so on up to Rn. So I can write, therefore R is equal to R1 plus R2 plus R3 plus and so on up to Rn if there are n number of resistors connected in series. So what you have to remember here is, when the resistors are connected in series, the current flowing through each resistance remains same. Remember this. Current through each resistance remains same. This is very important. This makes the difference between series combination and parallel combination. Okay. Current through each resistance remains same, but potential difference divides. Total potential difference V becomes equal to V1 plus V2 plus V3. As a result, we can apply Ohm's law and get the result. R is equal to R1 plus R2 plus R3. So let us solve one problem quickly and we will understand the meaning of series combination clearly. Okay, let us quickly look into this problem, very interesting problem. An electric lamp whose resistance is 20 ohm, electric bulb of resistance 20 ohm, and a conductor of 4 ohm resistance. This is the conductor of 4 ohm resistance are connected in series. They are connected in series to a 6 volt battery. This is 6 volt battery. If they are connected in series with a 6 volt battery, calculate the total resistance of the circuit. What is the total resistance of the circuit? Very simple. One is 20 and another one is 4. When they are in series, 20 plus 4 becomes 24 ohm resistance. Second thing, what is the current through the circuit? If the circuit is closed, see here, when the plug key, this is the key, when the circuit is closed, the current starts flowing. When the things are in series, when the resistors are in series, the bulb glows, of course, the bulb has a resistance 20 ohm. So, same current I flows through both. The current flowing through the circuit becomes I. Let I be the current flowing through the circuit. One can calculate the current. And the third point is calculate the potential difference across electric lamp and the conductor. What is the potential difference across bulb and what is the potential difference across the conductor? Three parts are there. So let us calculate one by one. First, A. Total resistance. Total resistance of the circuit. Total resistance R, since they are in series, we know if they are two components, then R is equal to R1 plus R2. Where R1 is the resistance of, let us take this one as R1 and this one as R2. R2 is the resistance of bulb. So R1 plus R2. R2 is 4 ohm and R1 is 4 ohm and R2 is 20. Therefore, total resistance becomes 24 ohm. So this combination acts as total resistance of resistor of resistance 24 ohm. Now this is what. Now let us calculate the current through the circuit. The current I through the circuit. By Ohm's law. Using Ohm's law. V equal to Ri. We have already found out what is R, where R is equal to R1 plus R2, 24 ohm. Therefore, I becomes equal to V by R. V is given here 6 volts. 6 volts divided by resistance. What is the resistance? 24. 6 ones are 6 fours are. So it becomes 1 by 4 ampere. So the current read by this ammeter is 0.25 ampere. 0.25 ampere. So this is the current. The third point, potential difference across electric lamp and what is potential difference across conductor. One by one we calculate. First, potential difference across the conductor. Conductor of resistance 4 ohm. Let us call this one as V1. V1 is equal to R1I. V1 is equal to R1I. We know what is R1? 4 ohm. And we know what is current? 0.25. Therefore, 4 into 0.25. 0.25 is 1 by 4. Therefore, it becomes 1 volt. 1 by 4 cancels with 4. Therefore, it becomes 1 volt. So, if the voltage across this one is V1 equal to 1 volt, then what is the voltage across the second one then? Total voltage is 6. 6 minus 1, 5. You should be getting 5 volts. So, that voltage is divided here as V1 plus V2. If V1 is 1 volt, V2 should be 5 because total voltage is 6. 6 minus 1 should be equal to 5. Let us see whether it is 5 or not using Ohm's law. So now potential difference, second one. Potential difference across the bulb of resistance 20 ohm. of resistance 20 ohm. V2 equal to R2I. R2I. Therefore, R2 is how much? R2 is 20 and the current is 0.25. So 1/4 of 20. 1/4 of 20 is 5 volts. So if you add this, therefore I am not getting V equal to V1 plus V2. V1 plus V2 is equal to 1 plus 5. Thus we are getting 6 volts. This is how we can verify. Okay, and this is how one need to calculate the current values, total resistance, and the potential differences. So let us solve. Yes, this is the one problem. So total resistance. You can also calculate what is total resistance by R1 plus R2 equal to 24. We got it. You can verify. How is this? 24. We got total potential difference. V equal to 6 volt. We got the current. Current is equal to 0.25. So what is total resistance? Using Ohm's law, V equal to Ri. So this implies R is equal to V by I. P is 6, I is 0.25. So I am not getting 6 divided by 1 by 4. So this is going to be 34 ohm. So this is how one can verify. Verification can be done using Ohm's law. So in the next we will study the parallel combination. Okay. Today I am giving you a problem. I think you have solved the problems which I had given you yesterday in the previous video. Please solve the problems and discuss in the group. The purpose of creating 10th ABC combined group for physics is to discuss such problems, and nobody is coming with solutions. So please solve the problems and discuss in the WhatsApp group, 10th ABC combined together physics group. Okay, problem is like this. Draw a schematic circuit diagram. Draw a schematic diagram of a circuit consisting of a battery of 3 cells, each of 2 volt. 3 cells are there. The combination of cells gives us battery. So 2 volt connected in series give you 6 volt battery. Just like the circuit diagram what I have drawn. Just refer that. Same way, the battery of 3 cells having 2 volt each means total voltage supplied by the battery is 6 volt. And then a 5 ohm resistor, 8 ohm resistor and 12 ohm resistor. It is not 12 volt, 12 ohm resistor. 12 ohm resistor connected in series. 12 ohm resistor and a plug key all connected in series. So you have to draw the circuit diagram. For this above circuit diagram, what is the ammeter reading? What is the current value? You have to calculate current, total current I. Total voltage is given 6 volt. Total resistance you can calculate. They are in series. 5 plus 8 plus 12, 25. Total resistance is 25. Then the total voltage is 6. So you will get the current I equal to V by R. You will get the current I. Then what is the voltmeter reading across 12 ohm resistance? What is the voltage across 12 ohm resistance? I think you will do it and discuss it in the WhatsApp group. Thank you. Have a nice day. Bye.